Hello, and welcome to video k equals 1, video number current equals k plus plus. The point is, we're on, or actually, wait, plus plus k, whatever. We're on video 2 of this series where we're doing the flatten method on the worksheet. So this method, I think, looks a little bit intimidating because it's really big and there's a lot of blanks here and there's a lot of loops and weird stuff, but we're going to go through it together and hopefully it will make some semblance of sense after we're done. After I finish writing the actual code, I will go back and kind of explain again some of the things that are going on because we're going to get rather technical here with a bunch of little kind of loops and stuff that we're incrementing. In particular, this, double for loop here might look a little bit intimidating. But anyways, before we get to the double for loop, let's look at what the method is actually supposed to be doing. So it takes a 2D array X, and it returns a 1D array that contains all of the elements in X concatenated together. And then it gives an example of what this means. I'm going to draw out this example just for the sake of clarity so you understand what's going on. So X is a 2D array. So let's draw X. So what is a 2D array? It's an array that contains other arrays. So in this particular example up here, the one that they're giving, we see that this array contains 3 subarrays, right? So X is an array of length 3. Typically we draw it like this. I'm going to label the indices, right? It's, this is how we would normally draw an array. It's just on its side because that makes it a little bit easier. And then it contains 3 subarrays. So each one of these is a pointer to a subarray. The first array contains 1, 3, 7. The second array is empty. I'm just going to symbolize it like this. It's not null. It's an empty array. It's a different thing. And then the third array is just a 1-element array with 9. So keep in mind, this array, I'm just representing it this way. It's actually a length 0 array, so maybe I should represent it more like this, but it's in this weird limbo space. It's not null, but it also has a length of 0, so whatever. Anyways, this is basically what X looks like, right? It's a 2D array, so it's an array that contains arrays. 2D arrays are really, really common. You probably encountered them in Project Zero. You probably had to write some double, triple for loops dealing with these 2D arrays. So hopefully you have some familiarity with them, but if not, we're going to look at them again, nice and easy. So the main thing to note about here, though, is that X does not contain any numbers. X only contains arrays. It's the arrays which X contains, which contain numbers. Okay, sure. So we do that, and we want to return 1, 3, 7, 9. So we want to return this, right? And you can see that we are not returning anything for here because this is a length 0 array. We're just squishing all of these together. So in the end, we want to end up with an array that is 1, 3, 7, 9. Yeah, that does not look like a 9. Kind of looks like a 9. Okay, hopefully you understand. Okay, so let's look at the actual skeleton code of the method. And this is a very good one for you to take advantage of the names that we have given you for the various variables we want you to have. There are some big hints there. Be sure to look ahead in the method if you're not exactly sure what to do on a particular line. That will probably help you out. Just a general tip when you're doing these kinds of skeleton codes is you should probably do the easiest parts of the method first. Take a big picture look. Don't worry about doing it line by line. It will all kind of come together in the end. So looking at this entire method, there's something that I see as the easiest line to fill out. Or at least the first line we might want to do. So notice that this returns an int array, right? It returns this array, it takes in a 2D int array, and we have this return statement here. Notice that we are also creating an array called new array, which is an int array right here. So I'm gonna posit that the thing we're returning is just new array. That's probably what that line is. It doesn't include a semicolon for whatever reason, so I'll put it on. That's probably hopefully somewhat straightforward. And if you ever get to an exam question or something and you really don't know what to put and it's a big skeleton like this is what you should do. Look for the really easy lines, the ones that are probably clear, and I guarantee you'll get points for it. Anyways, let's look at the method now from the top. So we're going to say new array size, and then we have a for loop after it. So knowing what we know about what this method takes in and what we want at the end, we can gather the new array size is going to be, in this particular example, 4. It's going to be, this thing, right? So notice, though, that there's no way we can get new array size in like a one-liner, right? Because remember, the new array size is the size of 3 different arrays, right? And it's also not just like the size of x dot length or something like that. Because remember, x dot length is size 3, right? It's the arrays inside of x that we actually want to be looking at the length of. Okay, so that means that we probably need to loop through x in some way in order to actually compute this new length. And if I look ahead a little bit in the method, I see that we have this for loop here where we are going to be incrementing something itself plus something. That's probably going to be where we're going through x and we're seeing the length of the arrays. And then what I see here is we're going to instantiate the new array itself. Remember, when you create an array, you need to give it a length. This is where we're creating the array, and we have this variable which is called new array size. So hopefully that's a pretty big hint of what we're trying to do here. So in short, I figured out that these 5 lines here are really like one thing, right? We're breaking the problem into subproblems. The first subproblem is creating this new array because we don't know how big it needs to be initially. Okay, so let's loop through. Normally when we loop through and add something up, we're just going to start a new array size as 0. So that's probably a good thing to start it as. And now we need to loop through x. So how do we write a for loop? Well, we're going to say int, in this case, I'm just going to use I equals 0. I is less than x dot length. I equals itself plus plus. If this is weird to you, you'll get used to it. You'll write so many for loops in this class that it will become second nature. But this is basically what we're doing. And this is a really, really standard thing. We're starting at 0 and we're just going through every element in x, right? What are the elements of x? It's this, it's this, it's this. It's these 3 arrays. Remember, it's not the numbers, it's the arrays itself. Okay, and so what do we want to do? We want to compute the length of our new array. So we're going to say new array size. I don't know why the thing is so small here, but basically we want to say new array size equals itself plus what? Well, what do we want to add first? The first thing we want is 3. We want the length of this array. So how do we get that? Remember, it is not x dot length. X dot length in this case does happen to be 3, but it's the length of this array, not this array, right? And so if you iterate through and you just add x dot length every time, you're going to end up with 9. So if you try to do x dot length plus itself, you will add 3, and then you will add 3 again, and you will add 3 again, which is not what you want. You want to add 3, then 0, then 1. Okay, so we don't want x dot length itself. We want the lengths of the things inside of x. So what we're going to do is we are going to index into x dot I dot length, right? X dot I is an array. So if we call dot length, we're going to get the length of that particular array. Okay, so this loop is going to go through, and when it's done, we are going to have new array size equal to 4 in this particular example, but hopefully you see how it adds up to be anything. I'm not going to run through the loop individually. You can do that yourself if it would help you understand it. Okay, and then finally, we see this int array new array. What are we going to do? Well, we just want to create a new array here. So it's going to be new int, and we have to give it the length. The length is just new array size, because that is what we just computed, right? So again, these first 5 lines or so, all we're doing is we're creating this new array. So I'm actually going to draw it over here too. It's called new array. It's an array of, in this case, size 4. And by default, every element in this array, when you create a new array, is zeros. I'm not going to write the zeros out because we're, of course, going to change them afterwards, but that's basically what we've done. So that's the first part of the method. So now let's look at the second part of the method. So if this first part was just to create the new array, you can probably guess that the second part is going to be where we actually fill it with the elements here. This is going to be a little bit spicier. So again, let's look ahead a little bit. So we see we have a 2D for loop here. 2D for loops, you might have encountered before, are typically used to iterate through 2D arrays, because 2D arrays often represent basically like a grid of items, like a rectangle. Here it's not exactly a rectangle, but you might imagine a situation in which these are all length 3 arrays in here, and then it would basically be a rectangle. And they're basically accessed via pretty much XY coordinates. We usually use IJ, but they're pretty much XY coordinates, right? Where you're saying where the X represents what array you are in inside of X, and the Y represents what element in that array you are in. So for example, here, if we wanted to get X0, 1 like this, we would first index into X0. So we would get this array. Then once we have this array, we would index into element 1, which is this 3, right? That's basically what we are trying to do here. Okay, so I'm not going to worry about new array index because I don't really know what that's going to be yet. I'm going to start writing the for loops because I know what they're going to be already, right? On top of that, we see here there's an assignment statement. So I'm guessing this is where we're actually going to fill the individual elements. And here is a plus equal statement. So we're going to do something with that. So let's just write the for loops. So we are going to say for int I equals 0 again, I less than x dot length I plus plus, right? Because remember, we just want to go through and get every array out of x. The second one is once we have every array, right? xi is an array, then we want to go through and get every element of that array. So this one I'm going to say int j because we need to use a different letter because I is already in use. And then we are going to say j is less than, what is j less than? It is not x dot length, right? Because we are going through not x anymore, but we're going through the subarray within x. So this is going to be xi dot length I plus plus, not I plus plus, sorry, j plus plus. Okay, and hopefully you can see there's a correspondence here, right? When we were first doing this part, see what we did. We went through and we said, okay, int I is less than x dot length, I plus plus. It is the same exact for loop here because all we're doing is we're going through every element of x, each of which is an array. Here, we are now going through and we are going up to x or x of I of length. Notice that it's the same exact thing here. Before we were just going through, we were figuring out what those lengths are. Now here we are using those lengths to determine how much we want to iterate. So we're doing a lot of the same stuff, just in a slightly different context. Okay, and then what do we have? We have this here, which is some assignment statement. And now it's becoming clear to me what new array index is. We're probably going to start at 0, and new array index, I'm guessing, is just referring to which particular index we are assigning at a particular moment. So if it starts at 0, we are going to want to first put something in the 0th index. So this part they definitely didn't give us enough space for, but it's basically going to be new array, and then it's a new array index, like that, right? We're just basically putting something in here. What are we putting in here? Well, we are putting x of I. We're putting whatever array we're on, and then we're doing j, which is whatever index of that particular array we're on, right? And then we are going to increment the new array index. We're going to increment that by 1 every time. Okay, that part was all a little bit fast, but I will try to explain in a little more detail and actually go through what's going on here. So I'm just going to run through what's going on here. So we're starting I at 0. This first line, we're starting, I'm just going to call this AI, which is like array index. We're starting that at 0. So we start that at 0, we start I at 0, we start j at 0, right? So what's going on? The first thing we're going to do is we're going to say, okay, new array of new array index, which is this, because this is just 0, is going to equal x of I. What is x of I? Well, I is 0, so x of I is this array, and then x of I of j. What is j? J is 0, so it's going to be the 0th element of the 0th array. So we're going to get that element, which is just 1, and put it here, right? Then we're going to go and we're going to increment j to be 1. And we're also going to increment the array index from 0 to be 1. So we're now looking at this one. Then we're going to do the same thing again. We're going to go to x of I, which is still 0. So still this array of j, which is now 1. So it's going to be 3. So we're going to do that. We're going to put a 3 in here. Then we're going to increment everything again. Then we're going to do the same process where we go here, we get this element, put the 7 here. Okay. So this is where things change. Sorry, at this point, j is also 2. This is where things change because we're going to go back to the for loop. And remember, j is 2. It's going to say, so j is 2. After we finish j is 2, j is going to be incremented to 3. And then we're going to say, okay, for j is 3, basically is j less than x of I dot length. X of I dot length is 3. 3 is now less than 3, which means that we are not going to run this interior loop being the one that actually does the assignments. We are instead going to go outside and we are going to run this exterior loop again, right? This exterior loop is going to increment I to be 1. Then it's going to set j to be 0 again, because every iteration is going to basically reset j to be 0. So this is going to be 1, it's going to be 0. And then we're just going to keep going again. So we're going to look at, we're first going to say, well, j is 0. Is 0 less than x of I is now 1, which means we're going to this array, dot length. This is length 0, is 0 less than 0. It's not, so this entire loop is actually going to be skipped. And we're going to do the same thing where we go up here and we're going to change this to be 2, this to be 0. And then we're going to run through again. We're going to get this and keep going. This is basically what we're going on. If this is confusing, don't worry, it'll become second nature at some point in the near future. If this is confusing, I would recommend that you yourself just kind of run this loop on paper and prove that it's actually working. You can try different x's of different lengths and different sizes and see if it still works for you. Okay, but anyways, that's the solution to part 2. I hope you enjoyed this.